Ready. Today we're going to look at the head-to-tail parallelogram method of analyzing vectors. So in order to have the head-to-tail method of analyzing vectors, we have to have some vectors. So we're going to put a vector A right here, and we're going to say that vector A makes an angle of 57 degrees with the x-axis. And that vector A is 180 newtons. And since this is the head-to-tail method, we're going to come over here and we're going to put vector B with the tail of vector B touching the head of vector A. And we're going to say that vector B is going to be 96 newtons, and that it makes an angle with the head of vector A of 72 degrees. Now, being that this is the parallelogram method, what we're going to do is we're going to come over here to vector B, and we're going to slide down vector A, and we're going to stay parallel to vector B, and we're going to draw an identical vector parallel to vector B with the same magnitude. And we'll do the same thing with vector A. We'll come over here and we're going to connect with the head of vector A pointing in that direction. So this is vector A. Now, the way we form our parallelogram here is critical, because you could go this way for your parallelogram, but what you need to do is look where the two tails of the original vectors join, which is right here at the origin, and where the two heads of the vectors meet over here, and you need to draw a diagonal across that parallelogram. And that diagonal that we draw, see if I can do this without messing up the board, is the resultant vector. So what we end up with here is a parallelogram that is bisected or cut in two with two triangles. This triangle with the black lines and the purple line, this one with the red and the purple lines. So we have two triangles here. Now, one of the things that we can do to find R is we can use what's called the law of cosines. The law of cosines says that R, which is this vector right here, is equal to the square root of A squared, vector A squared, plus vector B squared, minus 2 times vector A times vector B times the cosine of the angle that is opposite the resultant. And in this triangle, the opposite angle from vector R is 72 degrees. So we use our calculator now, and we say A, which is 180 squared, plus 96 squared, minus, and I like to use the parentheses key here, 2 times 180, which is vector A, times 96, which is vector B, times cosine of 72 degrees, close parentheses, equals And because it's under a square root sign, we have to take the square root of that answer, and we get 175.9 newtons is the magnitude of the resultant vector. So we just use the law of cosines to find the magnitude of r. Now we still need to find this angle right here that r makes with the x-axis, and we'll call that angle theta. Now if we're going to find angle theta, what we're going to have to do is go inside this triangle and find this angle right here, and we'll call it angle alpha, because if we can find angle alpha and we know that this angle is 57 degrees, to find theta all we have to do is subtract alpha from 57 degrees. And we can use what's called the law of sines. The law of sines says that r, which is the resultant vector, divided by the sine of the angle that's opposite r, which is 72 degrees, is equal to, and since side B is opposite angle alpha, we're going to say vector B divided by the sine of alpha. And we can cross multiply and find out that the sine of alpha is equal to B, vector B, times the sine of 72 degrees divided by vector r. So I plug into my calculator B, which is 96 times the sine of 72 degrees equals, divided by r, which is 175.9 equals, and that gives us the sine of alpha, which is 0.5190. If I take shift or second function sine, I get the angle is 31.3 degrees. So alpha is 31.3 degrees. This angle right here, 31.3 degrees. Now to find theta, we simply take the total angle, which is 57 degrees, and we subtract alpha from it, which is 31.3 degrees, and we end up with an answer that says theta is equal to 25.7 degrees. So our resultant vector is 175.9 newtons, making an angle of 25.7 degrees with the positive x-axis.